Welcome back. Today we are going to be looking at dividing polynomials. We just talked about in 5.3 what a polynomial was, and today we're going to look at dividing them, which is a little more complicated than adding, multiplying, or subtracting them, which is pretty straightforward, keeping in mind any domain restrictions or range changes that you have when you do that. Dividing them is going to take one extra step, and we're going to look at how to do that. And then in the next section, we'll see how dividing these polynomials can actually help us find zeros and x-intercepts for much more complex and much longer functions that we couldn't find beforehand. So it'll be a pretty short section today. We've really got two types of divisions, long division and synthetic division. So hopefully it won't be too bad, and you can get some skills that you need for solving and dividing polynomials. So let's get started. First thing we're going to do is we're going to talk about long division, which is going to take the form that most of all of long division from back in the third grade is taken, only this time we're going to do it with polynomials instead of numbers and integers. So instead of looking at this division algorithm, which you can definitely look at and read through in your textbook and see how it applies, I think it's better just to jump right in and show you the step-by-step process, how to divide, and then label everything after we've got an example of it. And then we can come back up and look at where this f of x and this d of x and this q of x and the remainder, where this all comes back into play. But I think it's a little easier once you've done it once to kind of feel out, oh, this is my remainder, this is my divisor, this is my quotient. That being said, so let's go ahead and jump right into it and do one long division. And then after that, we'll talk about synthetic division and the special cases in which we can do it. So the first thing we're going to do is we're going to identify our divisor, and we're going to identify our dividend. So because it says we're dividing A, or this red term, by B, or this blue term, the by is going to indicate which one, what we're dividing by. That is our divisor. We're dividing by our divisor. And so much like we would with any normal long division with integers, we're going to put that on the outside, draw a nice long division symbol from back in the day in the third grade, and then we're going to put that red term on the inside. 16x3 minus 12x2 plus 20x minus 3. Point out here, even though it didn't happen, that we want to check each exponent and make sure that the exponents are in descending order and that we haven't skipped any. Because if we did skip any, we need to add them back in. We need to add in a 0, but just so you see, check the 3. Next one should be 2. Next one should be 1. Next one should be 0. And if you're like, oh, where's the 1? Where's the 0? There's an invisible 1 hanging out right there saying that everything is to the first power is itself. And if you're like, oh, where's the 0? I don't see a 0. Well, if you throw an x right here, it's not 3x, but if you throw one there and you throw a 0 above it, anything to the 0 power is 1, and that x naught, or that x to the 0 would just be 1. 1 times 3 is 3, and it stays out. So your constant term always goes last. So because nothing was skipped, we don't have to draw a little arrow and add 0x squared or something like that in the middle. If it were missing, we would. It's just an important thing to check. So now what we're going to do is we're going to look at our terms. We're going to look at the leading terms of both the divisor and the dividend, and we are going to ask ourselves, how many times can 4x go into 16x cubed? Or a better question might be, what times 4x equals 16x cubed? And so in order to answer this, I'm going to think, well, 4 times what is 16? Let's pick a new color for this, maybe green. 4 times what is 16? Probably 4. And I'm going to, instead of putting it directly over the 16 right here, I'm going to move it over here because it's going to affect both terms. And then what times x can give me x cubed? Maybe x squared. And if this doesn't work out because the first terms don't cancel, we'll go back and pick something different. But I'm going to go ahead and say 4x times 4x squared is 16x cubed. And so now off to the side, I'm going to go and multiply. I'm going to multiply what I just picked as my quotient, as my answer, and we're going to multiply it by that blue term. And what we're going to end up with is hopefully that first term. If it's not, we'll repick it. 4, and we're going to distribute and go 16x cubed plus 20x squared. Take that term, throw it back in here. I'm going to keep it green so we can see this is on the green level. Go 16x cubed, perfect. They line up, they look exactly the same. We picked the right term to divide into. And then I'm going to write plus 20x squared. Note that the 2's line up, those exponent 2's line up. That's a really important thing. And we are going to subtract. Just like in long division, how you subtract a digit, we're going to subtract that whole thing. So I'm going to throw parentheses around it, throw a negative sign, distribute that negative sign, distribute that negative sign. And so now we have 16 minus 16. That's going to cancel out and give us our 0. That's perfect. That's what we want. And then negative 12 minus 20 is negative 32x squared. We're going to drop down the other terms, just like with long division of integers. And we're going to do it all again, maybe in a different color. So what color haven't we? Haven't used orange yet. And we're going to ask ourselves the same question, repeat the process. What times 4 gives me negative 32? Probably negative 8. What times 4, or what times x gives me x squared? X. Now I'm going to do the same thing over here. I'm going to take this negative 8x. I'm going to multiply by that blue term. 4x plus 5. I'm going to distribute, and I'm going to see what I end up with. Probably negative 32x squared minus 40x. All right, all the math looks good. Bring that back over here. What color are we using? We're using orange, negative 32x squared minus 40x. Draw your line. Add your subtraction sign. This is the step I see missed the most. The subtraction step is probably the most missed step in this thing, where you add a subtraction sign and distribute it. So negative turns into a positive. Negative turns into a positive. And we get our 0. Drop it down and we get 60x. Drop down that minus 3. And we're probably going to do this one more time. 4x goes into 60x how many times? It's a little harder of a problem. Red? No. Let's use pink. That'll be fun. 4x can go into 60x how many times? A positive 15. Hop over here, do it one more time, one last time. 15 times 4x plus 5. Do your distribution, and you should get 60x. That's going to cancel, that's great. And 15 times 5. Checking my math skills here, how fast I can do them in my head. Just to make sure, 75 plus 75. All right, now I'm going to bring that back down. This is the pink term, 60x plus 75. Draw a line. Don't forget the important step. Subtract both terms, so the subtraction and subtraction. And 60 and 60 go away. That's perfect. We want zeros all the way down. We want these zeros all the way down. If we don't have those zeros all the way down, we might have picked a bad term to divide, or a quotient term, and we need to go back and check and see. And then negative looks like negative 72. Nope, those are both negative. They add together. Negative 78. Be careful. All right, well, can 4x go into negative 78? We've got one last step. Well, I can't think of anything that multiplies by 4x to get me negative 78, and so I'm going to circle it and call that what we used to call it, our remainder. And so we've got ourselves an answer. We've divided. And so what we're going to do with that remainder is, if you remember back a long time ago when we did long division of integers in the 3rd grade, you would put that remainder over the divisor. And so we're going to do the same thing. I'm going to write my answer. I'm going to write the division answer, which is 4x squared minus 8x plus 15. I'm going to take that, I'm going to put a plus sign, take that remainder, put it on the top, take that divisor, put it on the bottom, and get a full answer for this division problem. And that is the step-by-step method on how to do long division. This is going to work anytime you need to divide two polynomials. It's really important to express the remainder in your answer and not just the quotient that you got at the top, because the remainder is a part of your answer. We'll talk later about what happens in the next section if your remainder is at 0, which is a special case, a pretty important case. But for now, we're remembering to put that remainder on top of that divisor as a part of our answer. All right, next we're going to move into synthetic, and then we'll call it a day. Synthetic division is a really specific case when we're looking for really specific factors where you have the form x minus k. Or sometimes in some books you'll see x minus c. It really just depends. It's x minus a number. Call it x minus 2 even. It doesn't matter. That number, k, has to be a real number, and we're looking for a specific case of division where it looks like that. There can't be a coefficient in front of the x. You can't have a 2 here. It has to be x minus c or x plus c, and you choose your c to be a negative number. We'll see that happen down here probably. Yep, we have a plus right away. So let's talk about the steps of division. Important side note to talk about is that you could definitely long divide these. We're just going to show you a little shortcut that we're going to be using a lot when we get into polynomials and finding zeros of polynomials, so it's worth exploring right now. So the first thing I'm going to do is I'm going to look at this and I'm going to say, oh, that looks like a special factor, or that looks like a special divisor. That looks like something that I could rewrite in a form that looks like x minus k, right? But because there's no minus sign, I'm going to throw a -7 right there. Say, oh, well, then k was going to be -7. So that -7 takes care of the minus sign for us and turns it into a plus sign. So our k value was -7. Sometimes they can flip-flop like that. It's important to remember that you want to use the opposite sign of the factor that you're dividing. All right, so here's how we set up synthetic division. It looks a little different, but I promise it makes it way easier. So here we go. We're going to put our -7 in the same place. We're not putting the x there. We're just putting -7 there. We're putting that k value there. We're going to draw this little backwards L thing, which is just the way everyone's done it forever. And then we're going to write out our term. Still keeping in mind, we need to check for those missing exponents. So we've got 4, good. 3, good. Jump straight to 1. That's where, I'm glad we have an example of this in the text. That's important. Star, 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 make a note. We're missing a plus 0x squared. We need to add that in our term. That way we remember to put it in our in our long division or our synthetic division. Either one, you have to have that 0 term there. You can't go on without it. If you do, you might get a wrong answer and you might not know whether it's a factor or not. So it's really important to remember those 0 terms. Let's keep going. 3, 2, 1, 0. We're good to go. Check for missing terms. Really, really important. I'm seeing if it says that up here. Write the coefficients, multiply the lead. Nope, it doesn't. But it does say it up here when you're talking about long division. In the steps for long division that we copied out of the textbook, it says set up division, determine the quotient, leading term. Oh, it doesn't. No, this is a really, really important step to make sure that you always have that 0 term in there. There'll be plenty of examples for us to practice with. So that will that's one side note on this whole section that's really important that I see missed a lot. Don't forget the 0 terms. All right, let's keep going. Sorry for that distraction. So we're going to take each coefficient, 3, 18, don't forget your 0, -3, keep that negative in there, and 40. Those are 5 different numbers. What we're going to do is we're going to drop down the 3 immediately. We're always going to drop down that first term immediately so we have somewhere to start. And then we're just going to go slowly, and we're going to do this 2-step process. We're going to multiply. We're going to take that 3 and multiply by that -7. So 3 times -7 is -21. And then we're going to add the new column that we have. So if we add that new column, we end up with 18. We end up with a -3. Then we're going to do it again. -3 times -7 is +21. Then we're going to write down that new number, 21. 0 plus 21 is 21. So don't forget, we're multiplying and we go around, and we're adding these 2 terms, keeping in mind what negative sign is already there. We're always just going to add the terms. The negative signs will take care of themselves. 21 times -7. That might be out of my scope to do in my head. Let's go over here. -7 times 21. 7 times 1 is 7. 7 times 2 is 147. Negative sign. It's okay if you have to go off to the side and do a little bit of math. I'm also in that boat. So we got -147. -147 plus -3 is -150. And I'm going to have to do it again out to the side. Multiply -150 by -7. -150 times -7, 0, 5, 3, 10, positive 1050. So we got a 1050 up here. And then we're going to add those 2 terms to end up with 1090. And now here's the really, really important part. So we got ourselves our answer. This looks like a bunch of random words where we just multiplied and added and multiplied and added. And what do we do with those? So I'm going to erase these. I'm going to show you in green what we do once we get our answer. We go to the last term, and just like in long division, we call that our remainder. And then we work our way over, filling in one bigger exponent every time. So this first term is going to be our constant, no exponent. This second term is going to have an x. This third term is going to have an x squared. And this last term is going to have an x cubed. And now if we're missing any plus signs, we add them in. We can leave the minus signs to take care of themselves. We can leave the minus signs alone. But if we're like right here, we're missing a sign. So we're going to add a plus sign in. And we got ourselves our final answer of 3x cubed minus 3x squared plus 21x minus 150. And then remember what we do with that remainder before? We add it, add 1090 divided by x plus 7. We got that x plus 7 from up here, from our divisor. And that is kind of an annoying synthetic because of the big numbers, but that is the method of synthetic division. If you need to pause and watch that again, or go to YouTube or Khan Academy and look up synthetic division so you can get the hang of it. It's a kind of tough process to get the first time you do it, but once you get good at it, you can move pretty quickly through all these synthetics. All right, one more practice problem, just because it's a pretty important concept to do the synthetic division. So let's say they give us the area, they give us the width. We know in our brains that area equals width times length. And so if we want to find the length, we would just divide. The length is equal to the area divided by the width. So see how we just divided the width across both sides, canceled out? Awesome. So we just have a division problem. They're giving us a specific example, a practical problem that has a long division or synthetic division in it. So let's check it out and we'll see what happens. So we're going to look at this x plus 6 as our factor or our divisor. And remember, plus sign's not good. We need x minus negative 6, which means that our k value is negative 6. So negative 6 goes on the outside of that L, and the inside's going to get taken. We're going to check for those zeros. 3, 2, 1, 0. We're good to go. They didn't skip any exponents. So now we're just going to write in the coefficients. 3, 14, negative 23, and 6. And here we go. I'm going to go a little bit faster just to show you that this synthetic thing, once you get the hang of it, can be not too bad. Drop down the 3, always the first step, easiest step. Just drop down that first coefficient and then get to multiplying. 3 times negative 6 is negative 18. Not too bad. Negative 18 plus negative 14 is negative 4. Negative 4 times negative 6 is positive 24. Be careful with those negative signs. Positive 24 minus 23 is 1. So we're going to multiply, add, multiply, add, multiply, add. 1 times negative 6 is negative 6. And this is awesome. 6 plus negative 6 is 0. I wrote it in red because that is our remainder. And if the remainder is 0, that means we don't have a remainder. We could still put it over the divisor, but 0 over anything is just 0. And so that means that our answer is a nice, neat factor. So we're going to backfill. We're going to say that's our constant. We're going to put in an x plus x squared, leave the minus alone, and we're done. We've done our division. And so our answer is going to be our length is equal to 3x squared minus 4x plus 1. And what we don't have to add our remainder, we've got 2 factors. That means that if we off to the side, just as a little like, what are factors? You remember like 24 has 2 factors of 6 and 4? 2 things that multiply by each other to get the top? Well, that's exactly what we did here, just with a long, ugly thing. So our original equation was this long area, right? And what we've just found is 2 factors. So I'm going to shrink this for now, and then we'll wrap up. I want to show you that all we've done is take our original equation, 3x to the third plus 14x squared minus 23x plus 6 is equal to 3x squared minus 4x plus 1 times x plus 6. And if we were going to FOIL that, or double distribute it, to take each term and distribute it, take 6 and distribute it, you'd find that you'd end up with that exact answer that we had for our original area. So what we did is we took a long polynomial and we factored it into 2 factors. And if you wanted to keep going even more, you could probably take that quadratic right there and factor it again, or use the quadratic formula to find 2 more solutions if you wanted to. But the answer to the question was the length that we got right there. That's the length. This is the width. And our total was the area. Thank you for watching. If you need to go back and practice some synthetic, there's plenty of exercises in the text for you to do that with. There's also homework that's going to be posted this week. I would highly encourage you to practice through the synthetic because it's going to get really important later on as we move through this course. Synthetic division is not going away. It's a new skill that we are mastering so that we can use it in future sections in this class. Thanks for watching this far, and I'll see you tomorrow.